All right, all right. Hey, y'all. Thursday, Powell Day of 2023. We are here to do some live coding. What we try to do each session is just think about what topics people are working on as they work through the Plutus PBL course. Yesterday, we had a chance to take a look at some unlocking transactions with Cardano CLI. Newman, thanks again for driving yesterday.
It's a lot of fun.
And yeah, man, the idea, everybody here, if you're working through the course, you're bound to have questions. And our goal is just to hear what questions people currently have at the start of each of these sessions. From those questions, jump into some specific topics and see what we can learn together. So who's got questions? What's the deal with SIP68? I like that one. Dan shared right before we went live this one.
Yeah. I ran into that. I'm doing module, the mastery module in 102, the assignment one to change my lucky number, which I'm really looking forward to. And I started researching the SIP68, the sort of core concepts that go along with that, which go along with the whole token sharing and, using it in this way of, like a course tracking, which is exciting. And what I found out is, so I found out some stuff, like it's a structured data thing, and it has to do with hashing the information, the datum, but I'm still getting used to all the different terminology in there. I did ask my assistant instructor, ChatGPT, and I'm going to paste its answer, the question and answer here for everyone's benefit.
We got Jingles here. Jingles, do you know of any better AI solutions for talking about Cardano?
Nice.
He's building one.
That's what I'm thinking. Yeah. That's cool.
But he's also probably chasing a tiny child around right now. So we'll just send you love.
Yeah.
Hey,
it's probably good enough, but it's not so updated. So that's the problem. And the knowledge about Cardano is all over the place. So I guess the best way to ask is a community like this, and sharing about knowledge and experience is the way to learn in Cardano.
You can train it on our course materials and maybe even transcripts of these live coding courses, and we'll try to make it smarter. This is a really important thing. And would everybody okay if we spent just a few minutes taking a really high level view of SIP68 just so people can get this concept? This is such a big deal, and it's incredibly exciting in the context of what we're doing here. I'm going to jump over to the course for just a moment. And this module right here, 203, has a purposefully misleading title, right? We tried to use a little bit of clickbait right here. 3 ways to mint an NFT. Oh, I want to mint NFTs. How? And what we try to do is, when you jump into this module, what you're really going to find out about is that we're going to talk about standards, okay? Because the entire first wave of Cardano NFTs adhered to one particular standard. It was the one outlined in SIP25. And you can read SIP25, okay? Just like we can read SIP68, SIP25 is here. And as of now, as we're rolling out this course in the first half of 2023, most Cardano NFTs are still following this standard, okay? If you think in your head of some of the most famous Cardano NFTs, it's likely they followed this one. There's a lot of applications on the web that know about this standard, right? So if you build a platform like JPEG Store or like Pool PM, where you can look at NFTs, the reason we are all able to look at our NFTs is that the builders of Pool PM and JPEG Store, for example, they know about this standard. So they built web interfaces for any tokens minted with this standard. But it's critical to recognize that this is not the only possible NFT standard that could ever exist. We can create other ones. And if we do, what adoption looks like is people building web-based tools or any applications that follow those standards and allow us to have that experience of looking at our NFTs. So if we look at the list of all SIPs, you could see that NFT, I'm just going to search this page for NFT. You can see, of course, it shows up for SIP 25, but there's work to do around royalties, SIP 27. There are experiments happening with something called smart NFTs, SIP 54, right? A voting NFT standard, right? And then we've got this one, 68, which talks about datum as metadata. Okay, so we have to start thinking about the distinction between these. And you can see there's some other NFT extended oracles. There's one for music somewhere. Doesn't look like it's up anymore. Oh, here, music token metadata would be a standard. Okay, so this is the context, understanding that we have several options. And in the course, what we try to show you is, right, that when we talk about 3 ways to mint an NFT, well, one way to do it, follow the standard that already exists. Another way, experiment with some of these new standards that are rolling out. Or number 3, if you really want to go rogue, invent your own standards, right? But if you have a problem to solve and the standard doesn't exist yet, you can create maybe what you need to create. Aris, what do you think?
Yeah, I think it's awesome. I'm wondering how does it work? Like, does the community vote on it, or is it based on how much ADA one has, or does it eventually go to IOHK and then they fix it, or like how does that process work? Thanks.
There's an open set of meetings. So basically, and Juan just had a SIP approved for addition to this list. I think we should be able to see it now. 93. Oh, it's not up here yet. But yeah, so this is a semi-decentralized process. It's still sort of orchestrated by different members of CF and IOG. But there's also a dedicated group of people, some of whom work at those organizations, but some of whom are just developers in the Cardano ecosystem who dedicate time to helping to administer this process, commenting on each other's proposals. And then depending on the type of proposal, there's different outcomes. So here, 31 through 33 reference inputs, inline datums, and reference scripts. These are 3 concepts that started as Cardano improvement proposals, and as of now have been implemented on the Cardano protocol itself. That's what happened at the Vassal hard fork last November. Okay, so it's possible that a SIP involves updating the layer 1, but that's not the case with SIP 25. All this says is, look, you can, if you want to, mint a token with transaction metadata with the metadata key 721, and you can follow this format right here. And the only reason this is a robust standard now is because a critical mass of people have decided to use it. But it's completely arbitrary, okay? The reason we can have NFT marketplaces is people who build those marketplaces choose to build applications that look at this metadata key and they read data that's formatted like this, and they give us the experience we expect of looking at JPEGs on a screen, okay? But there's nothing on the protocol level that that forces this to happen. This is purely, the agreement of a lot of people. What that means is if you write a standard that people start to use, then it's a standard, right? Like that's the idea. But it's got to be refined, right? It's got to be something that people can actually take on. So what's the key difference? There's a couple of things that are different here, but I just want people to kind of recognize this concept. And there's some videos to go along with this, okay, that show you, okay, metadata is what we use inside of a transaction itself, right? This is like the information on the receipt. It's not on the UTXOs that are being input or output. It's actually on the transaction record itself, okay? And that is where CIP25 metadata goes. Okay, so this video kind of takes you through that, and you can see the standard here along with links to what I was just showing you. Okay. The transaction is the event that happened. We could, it happened in time. It took some UTXOs as input. It created some UTXOs as output. Oh, and actually, I think I have a copy here on the PPBL Miro board that we're already using. Off to the side, these are the diagrams. So if you ever need to just use these raw diagrams, you can do this. So I can actually go through this. Okay, so if you want to mint an NFT according to CIP25, you basically are going to be creating some new token, right? Minting some new asset that's going to go into a UTXO, but the metadata itself, once again, is on the transaction record. CIP25 is not like this, okay? Or sorry, CIP68 is not like this. Here's a basic picture of CIP25. You make the transaction, you mint a token. CIP68, we don't need any transaction metadata. We skip that part. You could still include it for other reasons. But in CIP68, what we say is we're going to mint two different tokens at minting time. They're going to have a relationship. For now, it's in their name of the token, right? And maybe you've noticed that your PPBL 2023 token has the number 222 at the beginning of it, okay? That's your token that goes in your wallet, but when it's minted, all the way back at the start of the course, right? All the way back in lesson 100.4, you mint this token for the first time, and two tokens are minted. One goes to you, and another goes to what's called a reference address. And this UTXO at the reference address has datum on it. And that datum, for now, includes your lucky number and a list of modules you've completed. But it doesn't have to hold those things. It's just a place to start. There's a lot that's really interesting about this, okay? But with this idea in mind, and if you're just thinking about this for the first time, don't worry. This is a brand new concept, okay? And we're just trying to create some space to start messing around with it. But everything you see about your module completion status in the course is coming from datum in a UTXO with a reference token that's related to the one you hold in your wallet. And I want to show you for just a moment a little bit of Plutus.
Yeah, this is really wonderful. This is exactly what I was looking for, because I'm basically in that zone of trying to update that that lucky number, which now I understand. So I do have some questions, and I am looking forward, and I'm grateful for the space that we've created now to play with these concepts. It's good times.
Mike, thank you for helping to create it. Yeah, this is a new concept. I don't think we've even discovered what's possible with it yet. Right. So let's build up this understanding here. I'm just going to navigate within GitLab, and I'd like to look at this is the Plutus template we've been using in the course. Oh, no, actually, hold on. I didn't add it here yet. No, it's in a different one. Okay, no, this is not added yet to the Plutus template. But we can look right here. Contrib token, we have a validator here. And in this course, we haven't gone too deep into actually looking at Plutus code yet. We're getting there, okay? But I think we're ready to start seeing at a high level what's happening here. And actually, before I jump into this validator, you'll notice that in the same directory, contrib token, we've got the validator and we've got some types. I'm just going to open up the types first. And let me know if that's too small, if you can't see it.
It's pretty good. Thanks for making it big.
Good. Right here, we define this first iteration of contributor reference datum. And this should look somewhat familiar right here, right? What are the two things in the reference datum? A lucky number. And what type of data does that have to be? Oh, that has to be an integer. And then completed modules. And what's the data type there? Well, it's a list. Okay, you see these square brackets. If I wrap a data type in square brackets, that means I'm creating a list, right? So this is just a single integer. There's no brackets around it. You only get one lucky number, but completed modules, you could have one or more of those in a list, or zero or more of them, because when it's first started, you actually have an empty list. And what's in that list? Strings. The Haskell type is built-in byte string. We'll get more into the details of that later, but this is the essential type right here. And here's what I'm most excited about. Sorry it took that much background to get to this part, but this is the part that blows me away. When you interact with what we call the contributor reference validator, okay? And this, as you know, a Plutus script can be used to build a Cardano address. We looked at the always succeeds address yesterday, and Newman showed us how to unlock some UTXOs from that address, okay? This validator creates the address to which your reference token is sent and locked when you first mint your PPBL contributor token. Okay, so remember, at minting time for SIP68, 2 tokens are minted. You get one, the other one goes somewhere else. In this case, the somewhere else is right here. And because this is a contract address, we can set very specific rules for how datum can be updated. And watch this. There's 2 things we could update: the list of completed modules or your lucky number. And what this says here is, okay, suppose you want to update a lucky number. Well, the new datum is going to get a new lucky number from some redeemer here that's passed when you build this transaction. But who can do this, right? See how it says let in? This is a common Haskell structure. So we basically say, let these things be true, in this set of statements. And what this statement right here says is that the input to this transaction must have both tokens in your PPBL token pair, the one that was in your wallet and the one that was at this contract address. And what's the only way it could have both? Well, the person building this transaction must have their copy of their PPBL token, right? So if it has both, it means the one we're trying to unlock and the one supplied by the contributor or student in this case. And those names have to match. We're going to drop the first 3 characters off of each token name. Yours in your wallet has a 222 on the front. The one at the contract address has a 100 on the front. And that's just, this is an arbitrary standard, but it's the creative solution to the problem of matching tokens that's proposed in CIP 68. Hey, how are we going to know that this token goes with that one? Let's put a 222 on the front of the one in a person's wallet and a 100 on the front of the token name in some reference address, and everything after that 3-digit number has to match. That's what we say right here. Oh, well, look, we want to make sure that the token name from the one place and the token name from the other place, after you drop the first 3 characters, match. And if they do, we'll say, okay, you've got a pair. What this means is that only the owner of the contributor token can change the lucky number associated with that contributor token. In other words, Faizan can't change the lucky number on Nasty Honey Badger's contributor token. Okay. Martin, what do you think?
Say I create a token with the same name because I'm sneaky. How do you prevent that from working?
Excellent. So first of all, it would also have to have the same policy ID.
Oh,
Right?
yeah, that's more difficult.
So exactly, it's a little bit more difficult. Might still be possible. And in fact, all of the guards against nefarious behavior with the PPBL 2023 tokens as it's currently implemented, all of the guards for that are just in the front end JavaScript. We basically say, well, if we see a token in your wallet, you can't mint another one. But there's nothing stopping you now that you know how to use Cardano CLI to try to game this system. And if you know where to look, there's all sorts of ways you could hack this system. I told you there were Easter eggs in this course. Okay, so go try to hack it, try to break this thing. All right, that's incredibly exciting. But at least you're starting to understand, right? If the policy ID is protected by certain minting keys or even a Plutus minting validator, that gives us some degree of security. And it's up to us to make sure the tokens can only be minted when the proper conditions are met. Faizan, what do you think?
Yeah, I mean, I was having a query on line number 85.
Mm-hmm.
Yeah, the thing which is in bracket CS comma TN comma and underscore. Yeah, yes.
Yep.
So that CS and TN represent the redeemer, datum, and script, or is it something else?
Not exactly. So what this is doing, it says it's taking all input values, right? And
Yeah.
all input values is defined up here. Where does it come from? Well, it actually comes from the transaction info itself. And this is our context. Okay, so any validator, it's got a datum, a redeemer, and a context. Okay. In this case, we're saying, okay, the context, just get the whole info about this transaction, and we'll call it info. And then we can look at that TX info down here, and we could say, okay, and again, context is referring to the transaction in which this validator is trying to validate, okay? The only way to unlock tokens from a contract is to build a transaction. That unlocking transaction is the context we're talking about right here.
Yeah.
Okay. And as such, we could say, oh, well, show me all the inputs in the context in which we're trying to validate. Show me all the outputs. We can also look at some helper functions. So Plutus supplies a helper function called value spent, which just says, hey, look at all of the tokens, right? Tell me all of the value that's being consumed in this transaction. And that's what we then have down here, all input values. And then flatten value basically just turns the map. We'll go deeper into this, but for now, just recognize value consists of three things: a currency symbol, also known as policy ID, a token name, and the number of tokens. Okay. And that's flattened value just takes that map and it turns it into a tuple in parentheses. Okay, so flattened value, the output looks like this. We care about, in this case, the currency symbol and the token name, but we actually don't care about the quantity. And whenever you don't care about a certain value, you can just use an underscore in Haskell like this. We're going to ignore the number of tokens that are being sent here, right? And then we can say, okay, after, and this basically builds a list like that, right? And then we say, okay, after doing that, give us all of only the ones where the currency symbol matches the contributor token policy ID. It's likely you're going to have a bunch of other tokens, right? If you have one of those UTXOs, it's got a bunch of tokens in it. There could be some extra stuff here. All we care about is the contributor token. We expect there to be two, the one coming from the contract address and the one coming from your wallet, right?
Yeah.
And then we look at both of those tokens. We say, okay, well, listen, the list of the resulting list, this is called a list comprehension in Haskell. This is a deeper Haskell topic. If you're brand new to Haskell, don't worry about it right now. It's a very convenient tool, and the outcome of it is a new list. And what we're able to say, and this is part, when people say Haskell is hard, I think it's beautiful, but it's also hard because it makes us think a little bit differently than JavaScript, for example. But this basically says, look, you know what? The result of this list comprehension here, we know it's going to be a list. We know it's going to be a list. In the case where it's a list with exactly two items, do something. And in every other case, right, if there are not two items in that list, just return false.
Yeah.
Isn't that beautiful? It's so beautiful. It's so, right? Look at all the possibilities that could happen. If the possibility looks like this, do this thing. Otherwise, don't worry about it. But if there are two, not only can we say, hey, are there two items in that list? We can give them names. We could say, well, if there are two, well, can we call the first one A and the second one T? Those are arbitrary. It could be X and Y. You could give them names, whatever you want, right? And what we then say is, okay, look, the first item, this has to do with how just data is serialized and deserialized in Haskell. But what you need to understand is, look, we're taking A and we're kind of unspooling the token name here, and we're taking T and we're doing the same thing. And finally, here's that step I mentioned earlier. After you get those names in some legible form, chop off those first three numbers, see if they match, return true. The only way to return true is if you've got exactly two tokens and everything after the digits matches.
Yeah.
Oh, nice. And Faizan, you already got that part. Good. Good. Erez, what do you think?
Yeah, I have two questions. Can you scroll up a little?
Yep.
Yeah, so you said that I think it was validator has a datum reference and a script. What does the params, the first part do?
Excellent.
That was my first question. What?
This is an even juicier concept.
Yeah, so that was the first question. And the second one was, I was wondering if there's like a Haskell language server like HLS for extension kind of thing for these as well, that would kind of highlight what's going on and like clue us into.
There's a couple of options to your second question for VS Code. They're a little bit complicated to set up, but that would be a great additional module for us to supply at some point. And then to the first question, yeah, so in a spending validator, like you said, it's always going to be datum, redeemer, and context. Okay. Often the word action is used for redeemer because one way to use redeemers is basically as a statement of intent. In other words, I'm building this transaction so that I can update the completed modules, or I'm building this transaction so that I can update a number. These are our redeemers right here. Okay. But parameters are optional. And what parameters allow us to do is reuse the same exact code over and over again, but to recompile to unique smart contracts with unique contract addresses just by changing a couple of values. Okay, this is a big concept, and this is one of the most important things you will get out of module 204. When you work on the faucet project, you're going to build a parameterized version of a contract. We're all using the same exact validator, but we get to change some parameters and therefore each have our own unique instance. And this is an incredibly big deal, but let's save this for when people start getting their hands on that project. Now, to wrap this, okay, I kind of walked you through the update number logic. And at the end of the day, right, you can understand this part eventually, but at the end of the day, what it does is it says, look, if you have that pair, you can update your lucky number. That's this whole block right here. However, what if I want to update the list of modules you've completed in a course? The student can't do that. The contributor can't do that. The contributor can only change their lucky number. But if you want to update the list of modules, you have to be an admin. In this case, a teacher for this course. Now, the details, I hope that we have some really awesome conversations about what exactly the rules should be here in the months to come. We're going to get to the details, but at a high level, just understand this part. You can create on-chain data that tells the story of your token. You could include a link to an image, for example, that shows up as the picture for your NFT, right? And you can make it so that depending on what other token you hold or what role you have, you can update different parts of that datum in a precise and targeted way. This datum has the two fields we're aware of, list of modules and lucky number. Who can change the number? Only the holder of the contrib token. Who can change the list of modules? Only a teacher in this course. If a teacher tries to change a lucky number, it won't validate. They'll get an error when they try to build that transaction. And if a student tries to just add a whole bunch of credentials to their list of modules, they can't, because all a student can do is change their lucky number. And this I find this pattern so much more exciting than like minting a bunch of tokens, right? Like how many gimbals do you have? What does that give you access to? We can do that. That's trivial, right? But what about, hey, what have you done? How have you participated? right? And how is this datum keeping a record of that? And what are the rules for updating it? I'm fired up. I'm pumped to see where we go with this. What do you think?
Yeah, so does anybody got their hand raised up?
Not now.
Okay. Fantastic. Wow. I did not expect thank you and everybody for taking the time out from to make this, because yes, this did answer my question. What is up with changing my lucky number and what's up with SIP 68? It does seem like this is tied in very to the core of the course. And yeah, I'm excited. That's a really cool walkthrough. One point, the Haskell is a bit like, gobbledygook for me at the moment. It's a bit opaque. It's a bit in the fog. But Faizan says he can teach me. He says he uses it every day, and he says no problem. So yeah, I'm excited. And with that, I can, I know that code becomes front end. So to make a front end for this would be like really cool. And what might that look like? Yeah. So let's build it out. Let's do it.
It's so thrilling to be getting this concept out to everybody, right? This concept is more important than Haskell syntax, right? Because once you have the mental model of this and you understand why you're trying, like learning, I learned list comprehensions from the Haskell textbook. And I was like, yeah, I can imagine those are going to be helpful someday, but I have no reason to care yet, right? And so hopefully if you're building up these mental models right now, it's going to be pretty inspiring to dig into the actual Haskell itself. Martin, what do you think?
Where do you check the policy ID is the same?
Excellent. Good.
I only see the token name here. So
good. Actually, so this brings us back to Eris's question about parameters. So what we are saying is the currency symbol must be equal to this thing, contributor token policy ID param. But where does that come from? Well, param is just the arbitrary name we give here to the parameters. All right, so we have this parameterized contract, we pass it some param. And if I go back now to the types, you'll see right here, contributor reference params consists of two things. The policy ID of the admin token, right? What's the policy ID of the token that's going to allow somebody to be a teacher or an admin in this course? And the policy ID of your contributor tokens. And this is how parameters work. If I changed these values to something else, I would get a completely unique but functionally identical instance of this same contract, right? So you could reuse all of this right here. All the validation logic that I'm taking you through can be reused over and over again with different admin policy IDs and with different contributor token symbols. Where we actually define those values is in the compiler. This is the third file. So once again, right, we've got three files here. We define some types in types. We build some validator logic in validator, and then we compile here. This is not the only design pattern for building a simple spending validator, but it's a common enough one. Okay, and this kind of can help you see how a project fits together. But here in the compiler, look, we import the validator that we were just looking at. We import the types that I showed you a moment ago. And then we say, all right, what do we want those params to be? In this case, we want the admin token policy ID to be this, and the contributor token policy ID to be this. And if anybody has their wallet open right now, you can look at the policy ID of your PPBL 2023 token, and it is this right here. But yeah, this is another mind-blowing part to me. And I really want to help people get to this part. Like, look, you don't need to know Haskell necessarily, right? Teams are going to have their Haskell developers on the team, but maybe you're not one of them, right? If you just understand that parameters help you to reuse smart contract code over and over again, you drop your own parameters in there, and then you configure a front end, for example, to work with those parameters and the resulting smart contract address. There you go.
And how was it all? We've done this, I think. How does this policy idea originate? Is that from a contract?
In
Or
this case,
from a hash?
yeah, in this case, these are like really silly, simple ones, right? These, I think this one was made with 2 signatures, just one like a pre-prod signature I had sitting around, and an arbitrary additional minting key hash. Okay. But yeah, these could originate from a Plutus validator. You could create certain rules for how a token can be automatically minted. In this case, it's been kept pretty simple.
Oh, and if you want to make more, you need to have these keys to do the minting,
Right.
right? Yeah.
Right. But yeah, everybody here minted their contributor token without asking for permission, right? You just clicked a button and it was minted for you. And so if you're interested in taking on the challenge of just hacking this policy idea, I invite you to take a look at the source code for the course site. If you go into the module 100 source code, you can see the contributor minting component, and you can look at it and you can see where all those values are coming from and play around with it. I'll tell you, it's not secure enough to be an app deployed on mainnet. Okay. All right. Well, thanks for going on that detour. I've been looking forward to diving deeper into CIP68, and I'm sure we will again. Okay. But if those high level ideas make sense, that's pretty exciting.
I'm changing my lucky number.
Hey, nice. Nice. I'm going to jump back to the Miro here. So we started to think about this question, gave you a little overview there, but I hope people ask this question again. We'll keep going deeper. Because we just took half the time on that, let me just ask quickly today, would anybody object to troubleshooting module 102 and seeing this? This might actually come really in handy after thinking about contrib tokens together. But is there anything else people would want to throw on the agenda for today before we maybe just jump into that? Cool. Martin, would you be willing to drive on this one? And we can look at the error, and then if we need to, you can hand it back to me and I'll take us into the source code and try to figure out what's going on.
Is that me?
Yeah, was this yours? Wait, whose was this?
No,
I
it's
think
not
it
mine.
was.
It was me.
I think
It was
Dan,
me.
Dan.
Yeah.
Nice. Dan, are you willing to drive?
Yeah. No problem. I'm just trying to find the for some reason, Chrome has gone and closed the. What's it done? Hang on. I'm
Ooh,
just
and
finding-
where is this happening right here? Is this the contrib token or is this the
No,
font?
no, this is just the regular token minting, 5 ways to mint the token. Only the game changer tokens I received to my wallet, but the rest of the ones, like it is processing, but I don't see the tokens in my wallet for some reason.
Are you building transactions with Cardano CLI?
So I tried the Cardano CLI and Plutus TX. It's the same with both.
And are you seeing the message that the transaction was successful?
Yeah, I took a screenshot. I'll post it on here.
Okay. Yeah, let's see if we can zip through this one and then also look at that. The first thing that comes to my mind is maybe. Okay, yeah, so it built. Did you sign and submit the transaction?
Oh, I didn't do that. Yeah. Sorry. Yeah. Thank you.
Good things. All right.
That's great.
Right. Now, going back to my original problem,
Yes.
it seems to have cured itself now.
Which is actually more of a problem if you think about it. I would much rather an error happen consistently.
I was just opening up the browser page, and
Yeah.
I don't know if it was to do with caching or what.
Right.
It might have been to do with caching, but yeah,
There's a couple of things that are not optimized here. Yeah.
Could it be that Dan, are you running a node on your local node or Demeter?
Yeah.
Local node.
No,
Could be that
local
local.
node.
I wonder if it's that local node issue that we
No,
talked about.
because it's up. It was updating, and I could see it by querying the address using Cardano CLI.
Okay.
But it wasn't there. The front end wasn't showing it. I mean, I can share a window if you like.
Yeah, that'd be cool. Yeah, just to get the context of the issue.
Screen share. Share. Right, I'm going to share that one because then I can stick. Oops. Okay. Wake up.
Sweet jellyfish.
Oh yeah. Yeah, that's the latest Ubuntu. Yeah, you can see the that's the token.
Okay.
But it wasn't appearing on here. This was staying orange.
Oh.
Okay. So even though the CLI query showed it, it refused. Even if I disconnected the wallet, reconnected it, the CLI address and the split UTXO was showing up green, but the PPBL token was still orange. But now, for whatever reason, Chrome decided it was going to muck around, so I've had to reopen it, and hey presto, it's there. So I think it was a local cache on Chrome or something.
What do you think? I mean, yeah, that seems like that's a good spot. Is there another? The brain trust here? Was there something else that might have caused that? Has anyone else had that problem, etc.? Because that's what it feels like to me. Yeah, I mean that seems plausible that it just didn't. You know, somewhere that it was saying that it in the pipes in my mental model of what's going on sure there's some where it's not refreshing, and you turned it off and you tried to reload it. Connect.
I disconnected and reconnected the wallet, but I didn't shut down the instance of Chrome that I was running. So it's I think it was the browser cache, maybe.
Easy peasy.
I'm having a, yeah. Cool. I can carry on to the next bit now, can't I? So, actually, another quick question. You can see my node.
Yep.
Is coming up with all sorts of weird and wonderful information messages at the moment, rather than just extending the like just got a chain DB notice 40, which is an extension. But why does every now and then does it kind of appear to throw a wobbly and show all sorts of other stuff? Anyone know that?
Definitely. And what version are you running in the terminal window?
I'm running 1.356, I think. Hang on.
Okay.
Yeah, 1.356.
This is what's especially confusing is like, at least yours is still getting the extended chain new tip message, right? We saw with Newman's yesterday that for some reason this has stopped happening. And both things, right? This list of other messages you're getting here, governor, connection manager, peer selection, okay, and the bug, I think they're related somehow. And what it has to do with is that we're in this transition right now from the kind of federated, centralized network, right? So remember in the Byron era before Shelley, if we go way back, you didn't even have, all you had was IOHK running nodes. And now we've got 3,000 global stake pool operators. But the goal is for SPOs to be able to have their nodes communicating to each other in a more robust peer-to-peer way. One of the files you download when you start your node is called the topology file, right? And you specify that when you run Cardano node for the first time. The format of the topology is changing to incorporate this more robust peer-to-peer capability that's going online right now. But not everybody's using it yet. So you've got a bunch of operators on the network who are configured for P2P. You have a bunch who are not. And I think somehow these messages indicate that P2P work is happening, right? That I need to go a little deeper into understanding exactly what and what to expect. And at some point, this will just be the standard, right? And maybe it won't even be possible at some point in the future to use the legacy non-P2P topology.
Is it worth upgrading to version 8?
I think so. Yeah, I think
it's working now. Yeah.
Yeah. Yeah.
Okay.
You may find that you need to delete your database and start over again. I'm actually curious to hear what happens.
Okay, I'll try without deleting it and see what happens.
Yes, exactly. Pre-prod, that costs you a couple hours. Mainnet, that costs you a few days, right? So not a choice that you want to make lightly, but I'm see what happens.
Depends on how good our 4G is at the time, how long it takes.
What? So, hey, so updating the node. What's the latest node in its? What's the latest node version?
It's 8, I believe, .0.0.
Okay, and it has like a new, and it has a new structure, as a new different kind of, like it's a big. I mean, going from 1.3 to 8 is big, I guess.
Right. Well, so the reason they made that level jump is they wanted the Cardano node and CLI versions to match the Cardano protocol version. And
Right.
so we're finally those are now that's good. Moving forward, those will match. But you will notice, for example, when you run Cardano CLI query tip with the newest version, it's got some new information in it. So there are little things. Yeah, there's a Conway error that's enabled. And we can look at the change logs and see if there's anything else that jumps out of this.
Right. Is anyone interested in watching my node anymore, or should I stop sharing for now?
That was great. Thanks. Nelson, hey.
Hey guys, I hope that at one point we can talk a little bit about series of tweet exchanges between that happened between Charles and Sebastian from DC Spark. Sebastian suggested they they would like to build some Cardano node that is not based on Haskell, something like that. So like if we have a Cardano node that isn't maintained by IOG, something else. I mean, I have thought about it a little bit, and it might bring new problems, but it also becomes more decentralized, I guess. But I don't know how it looks like, but that's going to be an exciting future, having multiple Cardano nodes.
What's the latest right now from that public conversation? Have they been tweeting recently?
No, I don't think. It just stopped. So
I see Mix has some thoughts on that, but if I can jump in first, it's similar to what we were talking about yesterday in terms of kind of the CBOR representation of different things. Some people have already noticed that while on the one hand, you can build smart contracts in these different languages, Plutus TX, Aiken, PluTS, Option, Helios, the list will go on, right? We've noticed over the last few weeks that even though it's possible to compile down to UPLC from each of those languages, the precise result of what's at the end of that compilation pipeline is different, right? The same logic in Aiken versus Plutus TX leads us to different UPLC and therefore different contract addresses, okay? So now compare this to something similar, the serialization libraries. You can read through the Cardano ledger step by step and see exactly how a transaction is serialized, right? Standardized into this CBOR representation that goes on chain. But early on in the days of mesh development, we saw this challenge, which was that the serialization library provided by Emergo at that time and the way Cardano CLI was working, for example, wasn't hashing data the same way. Okay, so you could have the exact same data, you could serialize it with two different methods and not get the same hash. And that was incredibly frustrating to deal with, okay? So now, in the very same way, you could follow standards to build a new implementation of Node, but it has to be so precisely perfect in order for those two different kind of source codes to result in block production in a trustworthy way. It just feels like it's the same problems, but the stakes are even higher. Mix, what do you think?
Hey, James, everyone. Actually, the question Nelson raised is kind of related to what we were doing. Me and Adrian yesterday, we were trying to establish a private testnet, and he did something, and he was showing this to me. And we found very, very interesting thing within Cardano CLI. If it's possible, someone, I don't know if you can, James, share your screen. I want to show a very, very special switch inside Cardano CLI. And I want to expand your imagination, guys, and your
Let's try it.
spectrum.
All right.
So inside, if you do Cardano CLI -- help.
By the way, this is on version 8 right here. I was saying
No
like
problem, no
query
problem.
tip. You can see there's some
Oh,
extra.
yeah, exactly.
Okay. So
Cardano CLI -- help.
just to show everybody version 8.0.
Yeah. Help. And you see there is a whole set of command inside Genesis. So please type, James, inside the command prompt, Cardano CLI space Genesis, and then -- help. See, if you see around the end of that, there is a switch, very special switch called Create Cardano. Guys, we have a tool not only to think about a smart contract, nodes, all these things. We have a tool to create whole complete blockchain just by one switch. So if you think there is a problem, if you think you want to change something, nodes, absolutely you are free. It's already democratized. You can create and establish your complete blockchain. You can change your protocol version. And actually tomorrow, Adrian in a Smart Contract Gladiator is going to show this installing how to establish this private testnet. And I hope we can bring this inside the module for testing and optimization, because I think it would be the first time in whole ecosystem someone's creating video talking about how you can start your own blockchain, and inside it you can temper it. You can change. You don't like testnet magic number for one, put it any number you like. You want to change its fee, no problem. You want to test new contract address, hash, absolutely, you are free. That's your blockchain. You can do whatever you want. And regards to nodes, sure, if you want more nodes, no problem. Less nodes, no problem. You want to create Cardano as a proof of work, no problem. The tools are already available. It's already democratized. And maybe maybe it's a good place to maybe advertise this blockchain. Like you don't have same thing in Ethereum, or as far as I know, in other blockchain, that you can establish, you can initiate your whole blockchain, which can inside it have many things with just one command. That's all, one command. And there are some stuff that tomorrow we are going to talk about. For example, there is a fee, and that fee goes to whom actually. If you have a private testnet, it means you have private treasury, and how you are going to split that fee. And one more important, if you see those commands, there is a thing for key generation, Genesis, key delegate, key UTXO. Like what is UTXO key pair, delegate key pair, and Genesis? And what is the Genesis template? And I hope tomorrow we can look to it. And there are many things we can break it and enjoy this breaking the blockchain itself, like, you know, shaking the core foundation of Cardano. But yeah, I mean, if imagine if there is a disagreement, I don't know about the whole conversation. I haven't looked to the conversation, to be honest. But if there is a disagreement for some reason, then the tool is available to just simply create a sidechain or hard fork or something else. So yeah, we have the tools already, and maybe in future we won't have Plutus project-based learning. Actually, we will have blockchain project-based learning. So you will just start your blockchain, and, you know, maybe from 1 year we will talk about how each project can start its own blockchain. which like it would be like a multiverse of madness, but it's like multi-chain of madness. So yeah, I just wanted to show you this guy, and Nelson brought this point. So yeah, we have a tool for blockchain itself, not only nodes.
And even in that multiverse of blockchains, I can use the same signing key pair to generate addresses for each one of those blockchains.
Yeah.
And I can have the same key hash on all of them.
Actually, those are very special keys, James. Tomorrow we are going to see that those keys are not as we thought it is. Like these UTXO keys are the signing key. They are the S key. But the Genesis key are not pop key hash. Actually, It's kind of looked like a binary. And inside Cardano mainnet, we have 7 of them. And inside this private testnet, for whatever reason, it's 3. I mean, we can go for more, but it's generally 3. And that's some concept that I don't know is there any document about it or not. So these Genesis keys are something really special that we need. I mean, I'm excited to go through it and find out what they are, but they are not the normal key as we know of.
Thrilling. Okay, I'm excited about that one. Eris, what do you think?
Yeah, hey Ali, good to hear you. I'm gonna try to come tomorrow, but I am definitely confused regarding side chains and new blockchains and hard forks and everything. So I think that'd be really nice to have some more clarification on that. Maybe we can talk about that tomorrow.
Sure. But if I can make it very short, just imagine that the ledger, that book that we want to record stuff there, namely transaction, we can record other stuff inside it. And by other stuff, well, now we are recording transaction, but we can record other blockchain activities inside it. Not the whole activity. We will compress and batch those activities into a hash and record that hash. So a side chain is a blockchain that its record will be recorded or written inside its mother chain, mainly, or also known as mainnet. So in Cardano, that's a design. We have a settlement layer, which would be the Cardano. And settlement means all of these different chains, all of their hash or whatever will be written here, and we will be agreed upon this. And there will be other layers, other chains, other books, or other documents, and those will be maybe quite completely different. And some of them might be like Milkomeda or something like, it's Ethereum based. It's different, completely different. And we call that computation layers. And the thing is, not only this different chain or side chain, which is actually not the side chain, we can call child chain or something, because it's related to this main chain. But we have something also as called parallel chain. So imagine all this Cardano can be duplicated, and we have another Cardano, and then these two Cardano can talk to each other. So if we kind of care about the terminology, parallel chain and side chain can be actually used instead of each other. But the side chain right now people are referring are the second layer chain, the chains or the information that will be batched and hashed, and it will be written inside Cardano. But what this parallel chain or the actual side chain can talk to each other, that there is a protocol Cardano is working called Mamba, and those things will come, I hope, when Hydra comes. And like Hydra is same thing with, I say, is like a child chain. Hydra opens a very small side, again, the other side chain, but imagine that there is this tree of information. And one of these leaf would be, I don't know, so many information. It will be batched compressed to a hash, and it will be written inside Cardano. And once we have this technology, we can go with parallel chain and expand it. So this is the idea of scalability and, of course, interoperability between Cardano and other chains. But that's the thing, that's the switch. So in future, once we are ready, we can not only create side chains, like parallel chain, which I explained, also we can create these child chain. Again, people call it side chain. So I know these terms are confusing because there are different implementation of same concept, same term in different blockchain. But inside Cardano, right now, we are focusing on the chain, a blockchain or whatever, which at the end of the day, it will be written inside the Cardano. The Cardano we know, I mean the main. But in future, I don't know when the Mamba protocol will be implemented, we will have the actual sidechain or parallel chain. And by using that protocol, we can talk with other blockchain, such as Ethereum Classic, Polygon, I don't know, Polkadot, Ergo, and so on. So it would be like a town hall of this blockchain, and they can talk to each other. And talking, I mean, not just a recording, but verifying something like zero knowledge proof. So like they will verify. Like imagine you buy something on Polkadot or Polygon NFT, or you have ADA there, and inside all of them by code, not people or something, or not even a project. Everything will be at the protocol level, the infrastructure level. So that's the whole idea. When we will reach it, I don't know, but yeah, these terms are confusing. I agree with you.
Thanks, man. It's just, as I was playing around on my screen here, trying to figure out which of the files had the network magic in it. So it's the Byron Genesis.
Yeah.
Look, protocol magic 1, there it is.
Yeah, we can change it if you want.
And just like everything, right? So like, look, here's the Alonzo Genesis file, has a bunch of information. A lot of it has to do with the cost of running a Plutus contract, V1. And then in Voltaire, we got V2. So this.
And you know, James, Adrian suggested, why not create Plutus version Gimbal app? We can create a whole set of JSON under it, or Node, and our blockchain works with Plutus version Gimbal apps.
Right.
That's possible.
And then even so, for me, where it gets even more confusing is you will have, we're all going to be learning about the ability to create instances of Cardano for whatever purposes we want. And this is, I think it's important to note that this is not an adversarial thing. This is from the beginning what the expectation was. Okay, so if you're like me and you saw the original whiteboard video from 2017 and those 3 pillars that Charles stands up, right? This interoperability piece and this scalability piece, they both stand directly on the ability to A, create additional copies of the chain, but B, have ways for those copies to now coexist. So this is, it's incredibly exciting. But at the same time that we are standing up new copies of the protocol, the underlying protocol is changing over time, right? And so I'll be curious to see how much of a logistical nightmare it is. For example, okay, we started our own chain back on this version of Cardano. What is the process for a side chain taking on a hard fork event, right? To update to a new version of Cardano. And that's still out ahead of us. We don't have to worry about it quite yet, but this is happening, right? Everything that's going on with SIP 1694 about governance, or maybe you've been following the poll stuff, right? I I think that is a governance action, actually. If I type governance right here. Yeah. So now we've got this create poll and answer poll feature right here built into governance. That wasn't part of the Cardano protocol in prior versions, and we have that now. And after SIP 1694 is approved, you're going to actually add new parameters to the blockchain, right? How many people have to approve this kind of decision? And I think it's important for everybody to recognize, like, not everybody's going to be happy with the initial set of parameters, right? What is the voting threshold? What is the maximum or minimum treasury withdrawal, right? How many people have to agree to make X or Y or Z change happen? But just the fact that those are going to be parameters that are now native to the chain, to me, it dwarfs the question of getting those numbers exactly right the first time. I want to get them right. I hope we do. I hope we come as close as possible to people being happy with this thing as we can. But if you're not happy with those numbers, you're going to be able to stand up a new version of Cardano, right? With different thresholds. Oh, we want everybody to be able to pull from the treasury all the time. Well, we can make that version of the protocol. It's just tweaking a few values.
And about the resources, James, Adrian was running this on the system, and we checked. I mean, I asked him how much resource it's taking. Discord was taking much more resource of its system rather than this whole blockchain. So it was like it was like opening a song.
Yeah.
Like if you were playing a song, that was the amount of RAM and CPU it was taking. That whole private test. So.
Well,
it's really
if there's only one node on the network, yeah,
it was but it was 3 SPO, and the 3 SPO was running, like they were, and epoch was each epoch was, I think, around 1 minute. Each slot was 1 millisecond, so things were really fast, and the transaction were submitted less than 2 seconds. So Adrian was able to go from the initiating the whole GPTE to going to checking it denied less than 2 minutes, less than 3 minutes. Incredible. So imagine that testing even would be so much faster if we
could just drop this whole decentralization thing and just run the network on Adrian's computer, that would be easier for everybody.
Yeah, actually we were thinking, why not? I mean, Roberto has a laptop and a computer we can rely on. Dandelion. Well, I said that no, that's a forbidden thing. We should not talk about it. You know, Roberto would, kind of screaming at us. Really, you are going to put this on me?
He's a legend. Yeah. Just for anybody who doesn't know, whenever you query, whenever you open the Plutus PBL website, you are relying on GraphQL queries, and at the moment, those queries are being served from a humble laptop. Running in Roberto's home. Let's make sure that's not the case forever.
Yeah, sure. Great. Fountain is near. Maybe we can change that,
Fund 10 is near. For anybody who missed that, Catalyst Fund 10 will launch on June 21st. So 4 weeks from yesterday. Well, geez, that was a merry romp around a few different concepts. How's everybody feeling?
That was good.
Any burning questions we should pin for next time? Yeah, I'm overwhelmed by the feeling that the fund's just starting. It feels really good. Thanks for getting us here.
By the way, James, have you used ping also? Ping command instead of query tip?
Oh no. Show me, what do I do?
I haven't. I just saw it. I haven't tested. There is a ping command in Cardano CLI. You see that there is a ping command. Cardano CLI -- help, and there is a ping. So let's see what will happen. Like, okay, host port. I think maybe that's the thing that we can't talk with other nodes or other, with the client. This is new, by the way. This is the thing for version 8. This is that they just added. So I wonder if someone
and the socket, and then you can ask for other things. All right. I see. Invalid option, you.
I think we need to specify the error, like Byron or something, right? Or
It says,
there should be magic also.
oh, host or socket. You don't need both. Okay. Let's just try the host. There you go.
Okay, so.
Oh, right, but it does look like it's the wrong version, right? So, right, default magic. Let's say magic is 1. Oh, there we go.
Oh. This is so now that's P2P or peer-to-peer thing that's Cardano or IAG were just very talking about is actually this guy. Okay. I don't know who we are pinging right now, but I wonder that's the thing we can explore.
Cool. Quick ping. All right. Yeah, it's incredible what we could play with.
Yeah, it's just giving, it doesn't stop.
So that's exciting. So tomorrow, 16:30 UTC, and we had taken Smart Contract Gladiator off the calendar because we've been pretty inconsistent, but this sounds like it'll be a good one. So I'll add it to the calendar and just ping everybody on the Discord server with information about that.
Great. Thank you, everyone. Thank you, James.
Thanks, y'all. I'm so excited to keep exploring with you. I wanted to jump into just looking at some of the source code behind how these on-chain checks are happening from what Dan showed us, but we'll get there. And there's some cool stuff we can look at together regarding both Datum and the checks that are currently in place, because there's a lot of pathways we could follow to like next features. And I know that's where we're going. But for today, thank you. That was fun.
Great.
Thanks, everyone.
Thank you.
Thanks,
Bye.
everybody. See you soon.
Bye.